Okay, everybody, we're going to start Chapter 4, which looks at empirical methods of describing data, and we'll start getting more into more mathy stuff in this unit. We'll start with Section 4.1, measures of central tendency, as I call it. Okay, kind of takes a look at what the typical value in a set of data is. Okay, so the words measures of central tendency refer to what the typical value for a set of numeric data are. The four measures that we're going to look at are mean, median, mode, and sample proportion of successes. All right, so let's take a look at the meanings of these things. We'll go through some notation. We'll take a look at some example problems as well. Okay, so the mean, most of you probably, again, realize this already. It's the average. Okay, we call it the arithmetic average of a set of numbers. And how do we find this value? We add up all the numbers in our data set and divide by the total number of values there are. Okay, so the arithmetic average of a set of numbers, add all the values in the data, and divide by the total number of values in the data. Now in this class, we're going to talk about population means as well as sample means. And there's a difference typically between the notation we use for population. Are we dealing with the entire population here, or are we only dealing with a sample? For the population mean, we typically use lowercase Greek letter mu. Okay. And for our sample means, we typically use x with a little line over that, and we call that x bar. This will be the one that we use more likely than not in this class, okay? And again, that notation just means that we took a sample from the population and we're finding the average of the sample, okay? Now, in this class, we typically use the letter x to represent our variable. I don't care if it's the number of pets you own, the height, your height in inches, whatever, okay? X is typically what we use to represent variables. And just for some notational purposes and clarification, when I write things like x1 or x2 or x3, what I'm writing is, this is the specific value in the data that I'm talking about. So x1 just represents the first value in the data. X2 would be the second value in the data, X3 would be the third, so on and so forth, down to what I call X sub n, which represents the nth or last value in the data. Right, lowercase n typically represents our sample size, so we would have n such X values, 1 for the first, 2 for the second, 3 for the third, so on and so forth. Okay, now using this notation coupled with summation or sigma notation, we can kind of write out the formula for sample mean. Okay, I want you to recall sigma notation, also known as summation notation. That's this guy, capital sigma. And if I write something like summation as n goes, let's do it like this. Let's go I goes from 1 to 4 of x sub I. So take it back to Algebra 2 for a moment, where you first saw this kind of notation. And basically, summation notation is this symbol right here. And it means we're going to add a bunch of things up. Okay? And basically what we do is we sub in for this guy, which in this case is the letter I. So I'm going to sub in the number 1. I'm going to start at this number, and I'm going to sub every number in for I until I get to this last value, which is 4. All right, so, and I'm going to add everything together. So it sounds like a lot, but all I'm really doing is, look, I'm subbing in 1 for the letter I first. So I would have x sub 1. Plus, now I sub in the next number after 1, which is 2. Then the next number until I get to that top number. Okay, so if I was simply adding 4 x values together, this summation notation would represent that. Now, more generally, if I want, I could say, look, let's look at summation as I goes from 1 to n of x sub I. So now I'm starting with 1 again. I'll have x sub 1 plus x sub 2 plus x sub 3 plus, and I keep doing this until I get to whatever that last value is. All right, so I would have n such values, and at the end of the day, I would have plus x sub n. Okay, so that's exactly what this summation represents, is this sum of values. Okay, so you want to be familiar with the summation script. You will see it in this class numerous times throughout the semester. Okay, but with this now, we can write, a nice neat little formula for sample mean. Basically, if I want the mean of a sample, I'm going to add the first value, the second value, the third value, all the way until I get to that last value. And then what are we going to do? We're going to turn around and divide by the total number of values we have, which again is whatever that number n is. So here's a way of writing out x bar. This is what we're doing. We're adding all our values, dividing by n, the number of values we have. But I can now clean this up top using, that sum in our numerator right here is exactly this. So I can say, look, this becomes the summation from 1 to n of x sub I divided by n. Or if you don't want to divide the whole thing by n, you can factor 1 over n out front. And it's the same exact thing. Okay, so here's again a nice, neat little way to represent the average value using summation notation. Again, just wanted to take a moment to walk you through that as a reminder of stuff you saw likely back in high school. Again, we will see summation notation periodically in this class, okay? Let's take a look at some examples now. So I can blow this up a little bit. Okay. All right, so first example, going to be relatively straightforward. Let's say a sample of 4 observations on X represents the amount of time it takes to complete an online hotel reservation rounded to the nearest tenth of a minute. And let's suppose that the data are as follows. The first person was X sub 1 was able to complete their reservation in, say, 5.9 minutes. And yes, you can have a fraction of a minute. Let's suppose the second observation, it took that person 7.3 minutes. It took the third person 6.6 minutes, and let's suppose it took the last person 5.7 minutes. Okay, so we've got our data, we've got these 4 values. Okay, let me move it so it's a little more clear, hopefully, for you guys to see on your screen. Okay, that last one's a 5.7. Let me clear that up a little bit for you. Okay, so in any event, we got these 4 people, and now the question is, well, what is the average wait time? That should not be too hard. And then I threw in a couple things about rounding here, just to be careful when you're doing your web assignment, with these, how to round, okay? So in any event, if I want the average of this particular sample, I'm going to say, look, x bar equals. You don't really need to write out this fancy notation for me. You just got to know what to do, which is simply to do what? Add these 4 values and divide by 4 here. Okay. In terms of the notation, I could write it as 1/4. N is 4. We have 4 values. The summation as I goes from 1 to 4 of x sub I, and I'm taking 1/4 the sum of these values, x1 plus x2, so on. Okay, so again, pretty straightforward stuff here. If you punch that into your calculator, the actual average amount of time was 6.375 minutes. So that's the actual average amount of time. We're not rounding here. This is just what we got back, okay? Now, if we want to round to the nearest hundredth, okay, hundredth is 2 decimal places, so we look at the last number past that, the first number past that, I should say. And if that's a 5 or above, we round up. So this 7 is going to round up to 8. So instead of 6.375, we'll call that 6.38 to the nearest hundredth. Okay? To the nearest tenth, that's 1 decimal place. So that's 1 decimal place there. Again, I go to the right of that. I see that I have the number 7. That's going to round the 3 up to a 4. So we're looking at 6.4 minutes to the nearest tenth of a minute. And then truncated is basically when we just cut it off at a specific location. All right, so looking at this original value over here, it says truncated after the tenths unit. Here's the tenths unit, so I cut everything after it off. So we would just cut that off, and we will call that 6.3. That's truncated. Okay, so it's kind of like rounding, but not really. You're just cutting off everything behind that number. Okay, so again, you'll see words like truncated and WebAssign and rounding, so just be careful. Okay. Now, example number 2. Let's suppose we have a student that has 3 test scores of, well, on test 1, maybe they got an 80. On test 2, they didn't do so hot, maybe they got a 60. And on test 3, they got a 72. Okay, and assuming that all these weight the same amount, what is the student's test average right now? Okay, so we could say, look, we can add these numbers and divide by 3, and we can pretty quickly get this student's test average here. All right, and give me just a moment, because of course I don't have my calculator up. Okay, so 80 plus 60 plus 72, that's going to be 212 divided by 3. And we get an average of 70.6 repeating. Okay, so I'll just write it as 70.6 with a little line over it to indicate that it's repeating. Okay, so right now the kid's got somewhere between a 70 and a 71 test average with these grades. That 60 certainly bringing things down. Okay, what would this student need on the 4th test to bring their overall average to a 75? Okay, so students trying to raise the grade a little bit. What do we got to do to get that up to a 75? Okay, so basically here, what are we looking for? We're looking for the value of X4 such that the average of these 4 values is equal to 75 now. All right, so let's see about setting this up. Okay, different ways we can go about this. But think about it, if we wanted the average of 4 numbers, what would we do? We would probably add those 4 numbers, divide by 4, and we'd have the average. Well, that's how I'm going to play off this. Basically, look, I know the first 3 values up here. X1, X2, and X3, I know those. So I can add those 3 values, and it's now this 4th value that I'm calling X4 that I'm looking for. I'm going to add those values, I'm going to divide by 4, and I know that that will give me the average. And in this case, we know the average should be 75. So here's now an equation we can use to set up to solve for this missing piece of data. Okay, and now we can clean this up however we want. These added up to 212. So I'll just clean the numerator up of this fraction a little bit. Okay, now ultimately it's this that I'm solving for, X4. I don't want to subtract the 212 just yet. We got to get rid of that 4 in the denominator. To get rid of something in a denominator, you multiply. So I'm going to multiply both sides of this equation by 4. Okay, these are going to cancel out. I'm going to be left with 212 plus that X4 equal to 75 times 4, which is 300. Okay, and now we can subtract the 212. And it looks like this student's going to need an 88 on the 4th exam in order to bring their average up to a 75. Okay? So if you have any questions on that, please let me know. Let's move on to median. Okay? Let's move on to a median question, or a median concept. Okay. Now, the median is going to be, it's another measure of central tendency, and sometimes instead of seeing what the numeric average of all our values are, what we do instead is we actually look at the middle value. So the median is the number or average of 2 middle numbers. I should say the middle number or the average of the 2 middle numbers of a data set when values are ordered low to high. Okay, so very important that we put the values in order if they're not already. Okay, and it's either going to be the number in the middle or it's going to be the average of the 2 numbers in the middle based on, it's going to depend on how many values in our data set we have. Okay, so the way we define the sample median, again, is as follows. I'm going to kind of write it like this. It's the single middle number if n is odd. If we have an odd number of values in our data set. Sample median will be the average of the two middle numbers if n is even. If we have an even number of numbers, you'll see that we're going to have two numbers in the middle. Okay. A couple quick examples, like just to show you, if I have a small data set, say, 2, 5, 7, 11, 19, and right here we have 5 values, n is 5. So if n is odd, we should have one number right in the middle, and as we come in from both sides, we do. Okay, we can see that that number 7 is in the middle, so here our median is just 7. There's no fancy notation. Sometimes we just abbreviate it MED. Okay, the median is 7. However, let's suppose I had like a 6th value here. All right, as we work our way in from the sides, okay, we now have two numbers in the middle. And so what we do to find the median is we take the average of those two numbers. And again, notice here n was 6, so when it's an even number of values, that's when we're going to have the average of two numbers. So the median would be the average of those two numbers, which is what? 18 over 2 is 9. Okay? Now, in general terms, just something to note. Mean and median are both measures of a typical value. When data is skewed, the median is a better measure of the center than the mean. Okay, and the reason why is because of outliers. If data is skewed, there's typically like one or two really high values in the data or one or two really low values that are uncharacteristic. And what happens then is when we have these one or two unusually large values or low values, it drives the average up or down kind of inappropriately. For a quick example, and I'll come back to like this in a moment, I just have a little space here. Let's say I have a list of numbers that represent like salaries, like I've said, of like Walmart employees. Maybe you got people making 30 grand a year, a whole bunch, 32, 37, maybe a manager's making 45. Okay, and I'm just throwing some numbers out here, okay, and we've got these few numbers and a bunch of people making this much money. And then there's, again, that CEO who's making like, millions of dollars a year. These are in thousands, so somebody making $1 million, that's like 1,000,000. So there's a millionaire making $1,000. All right. Now here I have a set of 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. Okay. The median, let's see if I work my way in, the median here is going to be 32. Which is fairly consistent. It's a fairly ballpark act. For the vast majority of these employees, that's kind of a good representation of an average value. However, if I actually went on to compute the average here, right, and I add these 30s, and that's what I'm doing right now on the side here, is I'm just adding all these up, okay, and I got 1281, which is 1,281,000, okay, divided by my 1, 2, 3, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. And I divide that by 9, I get an average of $142,000 a year. Now look at the actual data itself, right? Is 142 around anybody? Does anybody even make that much money? No, so it's not really a good representation of the average. Okay, if I got rid of this 1,000 and then I just looked at the average of those numbers, yeah, then I'm going to have a number that's fairly consistent with the rest of the data, okay? And just again, kind of tell you what that would be real quick. If I add just those numbers and divide by 8, I get an average of 35.125 for just these. And that's really somewhere right in the middle here. But this clearly is not, okay? So the only point I'm trying to make in all this is that when data is skewed, the median ends up being a much more reliable measure of central tendency. it's going to be much closer to the vast majority of your data than the mean typically will be. Okay? So in any event, just kind of on a side note there, you want to know that. Now back up here. Okay, so now sometimes, like, you know, if I have 5, 6, 9 pieces of data, the median value can be found pretty easily, kind of working in from the sides like I did a moment ago. It's like you could use your fingers to cover these two, cover those two, then you're left with those, you know. When you have, you know, hundreds or thousands of pieces of data in front of you, you're not really going to want to try to find the median that way, okay? So there is a little formula that can be used to tell you where in your list of data the median can be found, okay? And that looks like this. The median value for a set of data can be found in the n plus 1 divided by 2 position. Okay? Seems a little weird, but that's what's going in here. In other words, it will be the n plus 1 over 2 number in the list of data when ordered from low to high. Sometimes I say like the n plus first over 2 number. Let me show you what I mean. Notice here where we had 5 values. N was 5. The median ended up being the third value in our data set, right? So if n is 5 and I plug it into that little formula, 5 plus 1 over 2, that's 6 over 2, that's 3. That tells me that the third number in this data set is my median, and it was that 7 right in the third position. Here's x1, x2, and x3. When n was 6, notice the median ended up being the average of the third and fourth value. So when n was 6, and I do that formula, 6 plus 1 over 2, notice you get back 7 over 2, which is 3.5. It's this 0.5 that is telling us that it's going to be the average of two numbers. It's going to be the average of the third and fourth value in the data set. So I go to the third and fourth value. Those are the two numbers we had. Circle to begin with, and the average of those two numbers. Okay? That's the idea here. We'll see another example coming up in a moment looking at this graph. Okay? The histogram below displays the number of people at a family gathering who are in various decades of age. So we have some members who are in their 20s, their 30s, up to their 90s, okay? Now looking at this graph, I could ask, well, how many people were at this gathering? Well, we have the frequencies along the left side, so we can see exactly how many people were in each group. All we're going to simply do is add those frequencies together. There were 2 people in their 20s, right? There's 4 people in their 30s, 4 people in their 40s. It looks like 5 in their 50s, 3 in their 60s, 1 in their 70s, nobody in their 80s, and then 1 person in their 90s as well. So total number of people, let's add those frequencies up. All right, and we get, let's see, it looks like there were exactly 20 if I've added correctly here, okay? So 20 people in this group. Now I want the median age group. And which group is the average or typical age, the median age? Now there's a slight skew to this if I go over this. Okay, these older people, there aren't too many of them, slightly drive up the average. All right, and I would expect the median to be somewhere near the peaks here. Okay, but we're going to find exactly which age group. Okay, so it's going to be the age group in the middle. Well, what do we have? We have 2 people in their 20s, 2 people in their 30s, so on and so forth. But look, let's use the formula. We know there are 20 people in the group total, so n is 20. So if I do 20 plus 1 over 2, that's going to be 21 divided by 2. That gives me 10.5. So what does that tell us? It tells us that the median age group is going to be between the 10th and 11th person in the frequency. Actually, I should say it's the average of the 10th and the 11th value. Okay, so let's count. From low to high, we had 2 people in our 20s. From 30s, we had another 4 people. Well, 2 plus 4, by the end of the 30s, we get to our 6 people. Okay, we're not up to the 10th or 11th person in our group yet. Now, when I add the next 4 people in their 50s, I am now up to the 10th person in the group. The 11th person in the group must be in their 50s. Okay, in this particular thing, the average is going to be right at 50. Okay, the split from the 10th person to the 11th person in the group is right at 50. So it's not even a median age group. 50 is right in the middle here. Okay, so the median age is 50. Okay, Now, just to kind of show you, suppose this wasn't there. All right, let's suppose that n is only 19 in this case. So if I do n plus 1 over 2, that's going to be 20 over 2, that's 10. So exactly the 10th person would be my median here. And we figured out that the 10th person was when we got to the top of that 40s column. So if this was the way the question was set up, it didn't have that last column, 90 to 100, the median age would be exactly 40s to 50, okay, that age group. But the way this one played out, the 10th person was there, the 11th person was picked up right here, 50 cuts that off right in the middle. Okay, so the median age group here is 50 when we include all the data. Now, describe the shape of the distribution. I did that already. This is slightly skewed left. The bulk of the data is over here, and one high value bringing up the average. So slightly skewed right, or you could call it positively skewed. If I said left a moment ago, I misspoke. Okay, it's skewed in the direction of the random age here, this random older person. Okay, so that's skewed right or positively skewed. And now the question asks, approximately how many people at this gathering were older than 45 years old? Now, if I asked how many people were older than 50, that wouldn't be too bad. I would cut this off. I would count all these people. If I asked how many people were older than 40, I would be counting all these. But here, I'm asking about 45, which isn't actually a number kind of well-defined down here. All right, so this is about using a graph to kind of do some approximations. All right, older than 45. Well, as I look at this, 45 would be right here, which is where in this interval? Well, from 40 to 50, 45 is right in the middle. So if you think about it, we had 4 total people between the ages of 40 and 50. If 45 cuts that bar right in half, you can assume there's probably about 2 people on either side of that age group. So you just take the proportion of the frequency that matches up to the proportion of the interval. Okay, 45 to 50 is half the interval, so I'm going to take half the frequency. So these 2 people plus these other 5, plus these other 3, plus this 1, plus this 1. Here are the total number of people approximately that would be over 45 years old. All right, so half the 40 to 50 interval, and then the rest of these intervals as they were, and we're looking at about 12 people approximately. Okay, all right. Next examples kind of combine the idea of both mean and median, really just some practice algebraically. Example 4, find all possible values of x3, the third value in data, such that the mean of the 3 numbers will equal the median. And let's suppose that x1 is equal to 10 and that x2 is equal to 30. We want x3. And the way it's worded, it kind of implies that there may be more than one such value that we could come up with, such that the average of these 3 numbers would equal the median of these 3 numbers. Okay, really what it comes down to is when we're dealing with median, we have numbers in order. So let's talk about some different cases we could form here. Maybe x3 is the largest of our values. Actually, I'm going to go small to large. Maybe x3 is the smallest of our values. Okay? In which case, if I'm setting up for the median, I would write the numbers like this. x3 is the smallest, x1 being 10 is the next largest, and x2 being 30 is the largest of them all. Okay? Well, now we have our numbers in order, which means we should be able to see what the median is if the numbers are in this particular order. If x3 is the smallest, it looks like the median is going to be 10. So here's how we can set up an equation now for this particular case. Look, I know that to find the average of 3 numbers, I'm going to add these 3 numbers and I'm going to divide by 3. So we have now set up for the average. On the right, I'm going to set it equal to what the median would be, and in this case, the median would be 10. So there is one potential case that we can go on to solve, okay? So let's solve this. I'm going to clean up the numerator a little bit first. That's 40, so I have x3 plus 40, all over 3 is 10. And now I'm going to, again, multiply both sides by 3. Get rid of that. And now if I subtract 40, I get a value of negative 10. Now, we assume that x3 was the smallest. Is negative 10 smaller than these other two values? Yes, it is. And if I do a quick check, first of all, you can see that 10 is the median. It's right in the middle. And if I find the average of these three values, I get that same median value back, so it checks out. So one potential value for x3 is negative 10, and that's if x3 is the smallest of our values. Well, maybe it's not going to be the smallest of our values. Maybe x3 is actually in the middle. Maybe it's a number between 10 and 30, right? If that's the case, our smallest number is 10, the median is x3, and the largest number is 30. And now again, just like I did in case 1, I'm going to use this to set up a formula. Okay, to find the average, I would add these three numbers and divide by 3. And which one is in the middle this time? Median is x3. Okay, so we have ourselves a little bit of a linear equation here. The variable x is on both sides of the equation, but no big deal. I'm going to do the same thing I did before. I'm going to clean up the numerator on the left. I'll write that as plus 40. I'm going to do exactly the same thing I did before. I'm going to multiply both sides by 3. So x3 plus 40 equals 3 of these x sub 3's now. And now I want to combine like terms. So I'm actually going to subtract x3 from both sides. On the left I have 40. On the right, if I have 3 of these x3's and I subtract one of them, I'm left with how many of them? 2 of those x3's. Just like 3x minus x is 2x. Right, 3x3's minus an x sub 3 is 2 of those x3's. And now just divide by 2, and we get that our next possible value is 20. All right, and if you list the numbers out, if it goes 10, 20, 30, well, that adds up to 60, and I divide by 3, I get 20 back, which is also the median, so that checks out. So there was a second potential value. It could be negative 10, it could be 20, but what if x3 is the largest of them all? So here comes case number 3. So the smallest will be 10, then 30, and now x3 is the ordering. I will add and divide by 3 to get the average, but now the number in the middle, the median, is set equal to 30. Okay, so it really depends on the position of the third value that gives us these different cases. Okay, and all that's changing is the right-hand side of each equation. Notice the left-hand side is basically the same. We're adding and dividing by 3. The right-hand side is what changes based on what the median is based on the order of the values. Okay, so here again I have x3 plus 40 over 3 equals 30. Multiplying by 3 on both sides is going to give me 90, and subtracting gives me a max of 50. And again, if I check that out, here's now the numbers. Very quickly, I can see 30 is the middle, and if I add and divide by 3, I do get 30 back as well. So these are the 3 potential values such that the mean would equal the median. Okay, let's extend that now to, instead of 3 values, we're dealing with a total of 5 values. When there were 3 values, there were 3 potential x values. You may be thinking that with 5 values, there could be upwards of 5. Actually, it's still only going to be 3. It's always only going to be 3. Okay, so let me kind of show you this here. So here are my first values. Let me give them to you. x1 we'll call 15, x2 we'll call 10, x3 we'll call 21, x4 is 4, and we want to find x5 again so that the mean and the median of the set of numbers will be equal. All right, so look. Here's what I'm going to do this time. First of all, notice x1, 2, 3, 4. They're not really in numeric order to begin with, and that's important, okay? I'm going to order these. I'm going to go 4, 10, 15, 21. So the numbers we have in order, 4, 10, 15, 21, we just don't know where x5 goes. Look at these cases I set up. And I'm going to go x5 smallest to largest. Maybe x5 is the smallest, in which case the data would be ordered like this. Maybe x4 is between 4 and 10, in which case the data will be ordered like this. Maybe case 3 now is X5 is in the middle. There's the ordering. Case 4, X5 is the 4th largest, and for case 5, the largest of them all. So these are the 5 potential ways that X5 could show up ordered in our list of data, right? Take a look at cases 1 and 2 together here. Notice the median value, regardless of where X5 was. If we're just flipping the X5 and the 4 around, that doesn't affect the median, right? The median is still 10. So that's really just going to be one case. For the third one, X5 is in the middle, and that's the only place we see it. So that's going to be its own case. But again, now look at the last 2 and notice whether X5 and 21 are flip-flopped, it doesn't really affect what the median value was. The median is still 15. All right, so there's really not 5 different cases here. There's only 3, and there's 3 equations, again, we're going to set up. So for the top one, let's do this. Let's say, all right, we're going to add our 5 values, and we're going to divide by 5, and now this one is going to equal 10 because that was what was in the middle. Okay, so there's one case. I'll just call that 1 up there. For case 2, it was the middle one. I'm going to add the values, but X5 was in the middle. So I'll set this one equal to X5. And for the third case, we're looking at these bottom 2 here, where X5 is one of the larger values. In which case 15 was the median. Okay, so again, just 3 equations to set up and solve for, and let's see what we get when we add everything up here. 25 and 25 is 50, so we get X5 plus 50 over 5 equals 10. Multiplying by 5 and subtracting, we get a potential low value of 0. That's one value that could be acceptable here. Okay, and we'd really look like case 1 in the ordering. For the second case, let's see, we've got our X5 plus 50 up top over 5. And I am going, that should be a little subscript, not a power. Okay, I'm going to multiply by 5, so that gives me X5 plus 50 equals 5 of those X5s. And let's see, subtract an X5, so 50 leaves me with 4 of those X5s, and when I divide by 4, I get 12.5. Would that indeed be right in the middle? Yes, it will most certainly be right in the middle here. Okay, so that was that case. And now the last case, when X is one of the larger numbers here, again, I have 50 plus X5 up top. Multiply by the 5, and that's going to be 75 this time. And we get a value of 25, which again is on the upper end of the spectrum here. Okay, no guarantee it's going to be the second to largest or largest. Here it ended up being the largest of the bunch, just the way it worked out. Okay, but regardless of the total number of X values you're dealing with, there will always only be 3 cases. Is the new value on the lower side, in which case this is the median? Is the new value the median itself, in which case it's this? Or is it on the upper side of things, in which case this is the median? Okay. So just a couple things to think about and be careful of. Okay, mode, very easy. Not going to spend too much time on this, but the mode is the most frequently occurring value or values in the data. Okay, it's the value or values that show up the most. Okay, looking at the frequency histogram above, it's easy to find the mode age group. The highest frequency was 5 in the ages of 50 to 60. So with this family gathering, the mode was the age group of the 50s. Okay, most people were between 50 and 60 years old. Now, you can have more than one mode. Any data set may have no mode. That's when every single number shows up exactly the same number of times. 1, 2, 3, 4. There's no mode in that data set. 1, 1, 2, 2, 3, 3. Even though the numbers show up twice, there's no mode. Everything shows up the same exact number of times. Okay, so when every data value shows up the same number of times, there's no mode. You might have one mode if one value shows up the most. You could have multiple modes. Okay, if I have a data set like 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, 5, 5, 6. Okay, the numbers that show up the most are 2 and 5. They show up 3 times each. Those would be the modes. Okay, the values that show up the most. All right, we don't do too much with that except to, again, look at peaks of graphs and sample proportion of successes. Okay, here's a little bit of notation. This is called p hat. And this is how we represent our sample proportion of successes. Okay, and it just represents the proportion of the sample who exhibit some characteristic. Okay, maybe again I go with dog owners. How many of you own a dog? And maybe, let's suppose that we have there's 43 of us in our class, including myself. I'm a dog owner, and let's suppose, like, you know, let's suppose I'm going to use S to represent the number of successes. It's called. That's like the frequency. So let's say maybe 25 of us out of the 43 own a dog. Well, our sample proportion, as we would call it, p hat, would just be that fraction, 25 out of 43. It's basically your relative frequency. Okay, and if you wanted to express this as some sort of a percentage, you can punch it into your calculator, 25 over 43, and, you know, that's about 58%. Okay, if I'm rounding to the nearest percentage. If I go a little further, I can go like that. That would be about 58.1%. Little less than 60% own dogs based on these numbers. Okay, but that's what p hat represents, and again, it just gives you, you know, in general, this percentage of people or our population have this, feel this way about that, whatever the case may be. Okay. And that pretty much wraps up this section. What I do want to do is do one additional example problem with you guys that should help you with one of the web assignment questions. You'll see something on WebAssign similar to this. Let's suppose I grade 21 exams, and the average now is 79. What would be needed on the next exam to raise the class average by 1 point? Okay, so I've graded, let's suppose I have a class of 22 students. I've graded 21 of these exams, and right now the test average is 79. When I grade that next exam, what would that student need to get so as to raise the overall class average by 1 point? In other words, I want the class average to now be an 80. All right, so let's kind of think about this in two lights. What do we know? Here's what we know. What we know is that the current average after 21 exams is 79. Okay, so basically if I have my first value plus my second all the way up to my 21st value, I don't know what any of these individual grades are, but if I add these 21 grades together and I divide by 21, my average is 79. Okay, that's what we know. What do we want? We want X22, that 22nd grade, such that the new average is 80. Well, let's set that up. I mean, what would that look like? That would be x1 plus x2, dot, dot, dot. I'm actually going to write it like this, plus x21. So there's the first 21 data values. Now plus the new guy. Here's the one we're solving for. And for the average, we'd now be dividing by what? Not 21, but 22. And we want that average to equal 80. So there's what we've set up. Now, ultimately, we're going to have to use this equation to solve for x22 because that's the only equation that has the thing we're looking for in it, namely x22. All right, and what are we going to need to know in order to solve for x22? Well, here's all the variables. So basically, we need to know one of two things. One, we need to know what each of the individual test grades were. We don't. Or, without knowing what the individual grades are, we at least need to know what this thing adds up to that I've highlighted in green. Well, that we can figure out from our purple equation. If you notice, that's exactly what's in the numerator over here. So while I don't have any idea what the individual test scores were, I can certainly figure out what they add up to, and then I can sub that sum in over here. And very easy to figure out what they add up to. I just need to lose the 21 in the denominator. So I'm going to multiply both sides by 21. And now I will see what that sum adds up to. So what's 79 times 21? That's 1659. So again, I don't know what the individual scores were, but they had to have added up to 1659. Now knowing that, I can drop it into this numerator for these values. So 1659 picks up all this, plus my 22nd exam over 22. And now it's a lot like some of the questions we saw a little bit earlier. I'm going to now multiply by 22. And 1659 plus my 22nd score is going to be, looks like 1760. And now I can subtract. And it looks like we're going to have to get a score of 101. So I don't know how realistic that is. That's the number we would need to get, though, when we graded the next exam. Maybe there's a bonus, I don't know. But again, this is similar to one of the web assigned questions, and don't be surprised if you get a value greater than 100. Just put it in as you get it. Okay? So in any event, that's 4-1, measures of central tendency, or the center of a data set, as the book calls it. And I will be coming out with 4-2 pretty soon. Okay, folks? So if you have any questions, as always, reach out to me. Now things will start getting a little more mathy, like I said, okay? You guys all have a great day.